Have you ever just put your phone on a charging pad and thought, how is this even working? It feels like actual magic, right? Something straight out of a sci-fi movie. Well, it's very real, and the technology is moving faster than you'd think. So let's get into it and explain the science behind sending power right through thin air.
For most of us, this is wireless power. We use these things every single day. Drop our phones on them and just trust that they'll work. You see the little light come on, the battery icon starts filling up, but what's really happening in that little gap between the pad and the phone? That's still kind of a black box.
So that's the million-dollar question we're going to tackle. How does electricity get from the charger, jump through the air, through your phone's case, and into the battery without any wires? I promise you, it's not magic. It's just some really, really cool physics.
Okay, so to really get our heads around this, you've got to know that wireless power isn't just one single thing. It's actually split into two big categories, and each one uses different principles to get different jobs done. Let's break them down.
Think of it like this. On one side, you have near-field power. This is for short-range, kind of intimate power transfer. It uses magnetic or electric fields. This is your phone charger, your electric toothbrush, even your electric car. Then, on the other side, you've got far field. Now, this is the really wild stuff. Beaming energy over kilometers using microwaves or lasers to power things like drones or maybe even satellites someday. But here's the key thing to remember. No matter which type we're talking about, the basic setup is always the same. You've got a transmitter that creates some kind of electromagnetic field, and then you've got a receiver in your device that catches the energy from that field and turns it back into electricity. Transmitter to receiver. It all boils down to that simple, elegant handoff. All right, let's start with the technology we all know and use every day, near field. It's time to finally pull back the curtain on that little charger sitting on your desk.
The secret sauce behind your charging pad is a principle called inductive coupling. Honestly, the easiest way to think about it is to imagine a regular transformer, the kind that powers electronics. But it's been split right down the middle. One half is in the charging pad, and the other half is inside your phone. There's no physical link, just a little gap of air. So let's take a closer look. See that transmitter coil, L1? The charging pad sends an electric current through it, which creates this pulsing magnetic field. Now, when you place your phone nearby, that magnetic field passes through the receiver coil, L2, which is inside your device. And that moving magnetic field, well, it generates a brand new electric current in that second coil. And that's what charges your battery. It's such a clean, clever transfer of energy.
And what's so cool is that this same basic idea is used absolutely everywhere. The little charger for your electric toothbrush, it uses it to stay totally waterproof. And then on the complete other end of the spectrum, you have these massive charging pads built into the ground that use the exact same principle to juice up an entire electric car. The physics just scales beautifully.
Okay, but what if you want to power things from a little further away? This is where it gets really smart. It's called resonant inductive coupling. And that word, resonant, is everything. It's just like having two tuning forks that are tuned to the exact same frequency. You strike one, and the other one across the room starts humming all by itself. We're doing the same thing here, but with magnetic fields instead of sound waves. We're tuning the transmitter and receiver to vibrate at the same frequency.
And this isn't just some theory, Back in 2007, a team at MIT actually did this. They lit up a 60-watt light bulb from over 2 meters away. This was a huge deal, a landmark experiment that proved you didn't need to be sitting right on top of a charging pad anymore. Mid-range wireless power was officially a thing.
And that, of course, leads to the ultimate dream scenario, right? Imagine one single power transmitter, maybe hidden in your wall or ceiling, that just powers everything. Your phone, your laptop, your speakers, all charging at the same time no matter where you are in the room. No pads, no cables. That is the future this tech is building.
Okay, so that's the close-up magic. Now, let's zoom out, like way, way out. We are leaving our living rooms behind and going to the skies and beyond with far-field technology.
This is called power beaming, and it's pretty much exactly what it sounds like. Instead of creating a general field around a device, you're creating a tight, focused, directional beam of energy, and you're aiming it straight at a receiver that could be miles and miles away.
The two main ways to do this are with microwaves or lasers. Microwaves are awesome because they're really efficient and they can just punch right through things like clouds and dust and rain. Lasers, on the other hand, can be focused into these incredibly narrow beams, which makes them perfect for hitting a tiny specific target from a huge distance.
So what can you do with this? Well, the ideas range from the truly epic, like giant solar power stations in space beaming clean energy down to Earth, to stuff that's happening right now,
For instance, that's a real experiment where a drone is kept flying literally forever, powered by nothing but a laser beam from the ground. Science fiction is officially becoming science fact. And get this, the efficiency here is just incredible. The special antennas that catch this beamed microwave power, they're called rectennas, can convert over 95% of the energy that hits them directly back into usable electricity. That's an astonishingly small amount of wasted energy for a technology this futuristic.
So we've seen the up close and the far out. To wrap this all up, it's worth remembering that this whole new idea, well, it's actually a very, very old dream.
Over 100 years ago, the brilliant, visionary inventor Nikola Tesla was completely obsessed with this. His famous Wardenclyffe Tower was supposed to be the first piece of a massive system designed to cover the entire globe in wireless energy.
I mean, his vision was immense, maybe too big for his time. He wanted to use the Earth itself as a massive conductor to send not just information, but raw electrical power to anyone, anywhere on the planet. The project didn't work out, but that core idea, that dream, it never really went away. And in a way, we're finally seeing Tesla's vision come to life. It's just splitting into those two paths we've been talking about. We've got the practical near-field power that makes our day-to-day lives just a little bit easier, and we've got the ambitious, far-field power that could one day fuel our cities or our adventures in space.
So that world without wires that people like Tesla dreamed about, it isn't a fantasy anymore. It's being built right now, piece by piece, from our phones all the way to outer space. The wireless dream is finally here. So the only real question left is, what are we going to power next?